Good morning, students. So, we will start a new chapter today, that is the conic sections. So, there are some parts in this chapter, that is circle, parabola, ellipse, and hyperbola. So, we will cover these 4 topics under this chapter, conic sections. So, now what is conic section and why this all 4 geometrical shapes are called conic sections? So, first of all, if we take these 2 lines, first one is fixed, that is, take this line is fixed line and name it L, and take a point V and another line M, and their angle between these 2 lines is alpha. Now rotate this line M in this direction, so it will form a double napped right circular cone, right? So when this line M just rotate about this line L, so it will form a right circular, double napped right circular cone, where this is called the axis, okay, and axis is the line L, and this line M is called generator, which is M, and this angle is called alpha, and this is called, this point is called vertex, and this is called lower nap, and this is called upper nap. Okay, so this is the angle between the axis and the generator. Now, if I take a plane and if we find the intersecting portion or the intersecting surface between the plane and this double napped right circular cone. So either it will cut, this plane will cut this double napped right circular cone at the vertex, right? It will passing through this vertex, this point, and it will divide this figure into 2 parts, that is the upper nap and the lower nap. Now if it is not passing through the vertex, it is passing through any of this upper nap or lower nap or both in a certain angle. That is, if we just take this line, so this plane will make angle with this axis is beta. This angle is alpha, that is the angle between axis and the generator is alpha, and the axis and the plane is beta. Okay, now according to this beta, it will form some particular geometrical shapes, which is called a conic section. So now, if the value of this beta, that is, if the plane makes angle with the axis is 90 degree, that is, if beta is equals to 90 degree, then what we will find? So that will look like that. So this is beta, which is 90 degree. Right. Now if we just remove this plane and just talk about this sections, that is the intersection portion, so it will look like that, right? So that will form a circle. Okay, when beta is equals to 90 degree, the section is a circle. Now next, if this alpha less than beta less than pi by 2. That is the angle between the plane and the axis of this double napped right circular cone. This angle is greater than alpha, is bigger than alpha, but lower or smaller than pi by 2. So it is between this alpha and the pi by 2. So if this case happen, so it will look like that. The plane will passing or cutting the sections, its upper half, into an angle beta. Okay. Now, if I just remove this plane and just talk about the cutting sections, so it will look like that, right? So this is called a ellipse. So when this alpha less than beta less than pi by 2, it will form a ellipse. Next conic section is, if we take the same double napped tricircular cone and take beta is equals to alpha. Beta is equals to alpha. That is the angle between the axis and the generator is equals to the axis of intersecting this plane and the axis. Okay, so it will look like that. So this angle I am talking about, this is beta and this is alpha, which are equal. So if we just remove the plane and talk about the conic, that is the portion, so it will look like that. So it will form a parabola. And the next one is the hyperbola. Now, if this beta is less than alpha, that is, it's greater than 0, but it is less than alpha. So that time the figure will look like that. The plane will cut both the upper half and the lower half. Okay, and if we just remove the plane and just talk about the sections, so it will look like that. So this will form a hyperbola. Okay, now, so these are the conic sections. So every shape is different, every definition is different. Now, what is the proper definition of conic sections? Is cutting the plane is intersecting the conic, that's why it's called conic section, or there is a proper definition? So there is a proper definition of conic sections. Okay, so this 4 figure we can find, that is the circle, ellipse, parabola and hyperbola. And the definition of the conic section is like that. A conic section or a conic is the locus of a point P which moves in such a way that its distance from a fixed point always bear a constant ratio to its distance from a fixed line. Okay, definitely all are this in a same plane. So if I take a fixed point, suppose here S, and a fixed line, suppose let us take this is N, then we will find then the locus of a point P, if this is P, this distance and this distance always in a constant ratio. Suppose this is M, this perpendicular from P. So if this is the fixed point and this is the fixed line, so this distance PM and SP, these two distance are in always a constant ratio. Okay, now what is this fixed point called? What is this constant ratio is, and what about this fixed line? Okay, so just go through this conic definition of the conic section. So in this definition, we will find a fixed point and a fixed line and a constant ratio. Right? So this fixed point is called focus. This fixed point is called the focus of the conic section. And this fixed line is called directress of this conic section. And this constant ratio is called eccentricity, and we define this as small e. Okay, depending on this ratio, we can find different conic sections. Now, this axis. Now, what is axis? The straight line passing through the focus and perpendicular to the directress is called the axis of this conic section. So when we will discuss about the conic sections like parabola, hyperbola, ellipse, that time we will figure out which one called axis, which is vertex, which is center. But for now, just go through the definition of it. So what is the definition of vertex? The point of intersection of a conic section and its axis. So the conic and the axis, the intersecting point is called the vertex. And the center is the point which bisect every chord of the conic passing through it is called the center. Okay. And last but not the least, which is lattice rectum. So the lattice rectum is a line passing through the focus and perpendicular to the axis. Okay. So these are the definition, and by the definition of this conic section, we will find the general equation for the conic section. Okay. So according to the definition, we need a fixed point. Suppose let us take this is S alpha comma beta, and we need a point H comma K, and we need a fixed line. Suppose this is X plus By plus C is equals to 0. Okay. So let us take a fixed point which is called focus. Let us take a fixed line which is called directress. That is X plus By plus C equals to 0. And let us take this eccentricity E. That is the constant ratio is E. So let us take another point M. When we take the perpendicular from P, when draw the perpendicular from P, and it will cut this line, fixed line at a point M. So this distance PM and SP are in always constant ratio, which is equals to E. So we can write SP is equals to E into PM. Since the ratio SP is to PM is E, so we can write SP equals to E into PM. Now take the square both sides. So SP square is equal to E square into PM square. Now notice one thing. What is SP? The distance of these 2 points, P and S. What is PM? The distance between this from the point P to this line, X plus By plus C equals to 0. Now we can easily find the value of SP and PM. So SP is the distance between 2 points, that is H minus alpha the whole square plus K minus beta the whole square. And PM square is, just put HK into this equation of the straight line. So H plus BK plus C by root over A square plus B square the whole square. Right? Now if we just break the square and simplify it and just put in the place of HK X and Y, so we will find like X minus alpha square plus Y minus beta square is E square into Ax plus By plus C by root over A square plus B square the whole square. Now break the squares and just multiply by A square plus B square. So we will find this equation, right? is equals to a square into a square x square plus b square y square plus c square 2abxy plus 2bcy plus 2acx. Now take all the terms into your left hand side and just replace the constant in a complex form to a simplest form. So it will look like that's ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equals to 0. I'm just replacing the constant in a complex form in by a simple. So coefficient of x square will be a square plus b square minus e square a square, right? So this is I'm representing by small a. So like that, just simplify this equation and put this constant ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equals to 0. So this second degree equation, this general second degree equation for the conic sections. Okay, if we put the restrictions over here, we will find a particular conic sections like circle, parabola, ellipse, hyperbola. Okay, so when we will discuss the each part, that time we will discuss the general equation individually. But for the general equation, second degree general equation for the conic section is represented by this equation. Okay. So in the next class, we will talk about the circles, its forms, standard forms, its general forms, its equation, how to convert the general to standard or standard to general. So all this about circle we will talk about in the next class. So if any problem or any confusions or any doubts are there, so you're free to ask. Thank you.